Dear friends, good morning. Today I am going to discuss the concept of laws of thermodynamics. These are some learning outcomes of basic concepts in laws of thermodynamics. Basically, thermodynamics is the heat power or heat capacity. As we know, thermo means heat and dynamics means capacity or power. Heat engine is a device which extracts work as thermal energy flows from a hot reservoir to a cold reservoir. Two types of heat engines, one is external combustion and another is internal combustion. We are going to see the four laws of thermodynamics. One, zeroth law of thermodynamics, which is related to the temperature of system. Second one is a first law of thermodynamics related to internal energy of system. Third one, second law of thermodynamics related to entropy of system. And fourth one, the third law of thermodynamics related to absolute zero, unattainable. These are some key terms that we are going to discuss. Here we can see the difference between system and surroundings. The system is the confined one, the composite one, and whatever outside the system is nothing but the surrounding. There are three main types of system. One is open system in which both matter and energy can exchange. Second is the closed system in which only energy can exchange. And third one is isolated system in which neither matter nor energy can exchange. This is the justification of zeroth law of thermodynamics, in which if system A is in thermal equilibrium with system B and system B is in thermal equilibrium with system C, then system C will be in thermal equilibrium with system A. So this is what the representation of the thermodynamic equilibrium, in which we can say a system in thermodynamic equilibrium when they are in thermal, mechanical and chemical equilibrium with each other. We can define the work done in terms of the capacity of to do work, so called the energy. So work required is nothing but the difference between the final and initial internal energy. Here we can express the first law of thermodynamics, that is the change in internal energy delta U of a system is the sum of the work done on the system delta W and heat delta Q transferred to it. The two ways in which energy can be transferred into or out of a system by means of heat and work, so that when there is exchange of heat and work, the internal energy of a system changes and work has been done. So this is the isothermal process in which the system changes from initial state and reaches to final state. So in this way we can find out the work done in this process in terms of W is equal to nRT ln of Vf upon Vi. This is the justification for how to elaborate the work done in isothermal change or the isothermal process. There is another important process, so called the adiabatic process. So we can find out how the work is done in adiabatic process. So this is the expression for the work done in adiabatic process. Here we can express this work done, W is equal to 1 upon 1 minus gamma into T2 minus T1. So this is the expression for what is work, what is heat, and the internal energy of a system, which is the addition of kinetic energy and the potential energy of the system. So this is the relationship between the specific heat at constant pressure and the specific heat at constant volume. This is also known as the Mayer's relation, and this gives the Cp minus Cv is equal to R, the capital R, which is the gas constant. The second law of thermodynamics is all about the transfer of heat from hot reservoir to the cold reservoir. There are two statements given by the Kelvin and the Clausius of the second law of thermodynamics, in which heat cannot pass from a body at a low temperature to one at higher temperature without work being done. So in this way we can find out the efficiency of the heat engine when there is a transfer of heat from hot reservoir to cold reservoir. So this is important article in the thermodynamics which was expressed by the Carnot. So called it is a Carnot cycle, in which there are 4 processes, and this is most efficient cycle for an engine which converting a given amount of thermal energy into work, and we can find out its efficiency in terms of a temperature scale. The concept of entropy is denoted by the capital letter S, and we can define this entropy as a measure of the disorder of its matter and energy. So in this way, the change in entropy is nothing but the delta Q upon T, and here we can define the second law in terms of entropy. The entropy of a universe increases during any spontaneous change. Thank you very much. So we will continue in next lecture. Have a nice day.